Calgary. I promise I care about you. Well, that's a different lecture of mine. Yeah, so yeah, my main point that I'm making is that one of the big things about working in an object-oriented language is trying to figure out how things will go into things. So like when I did the two-player game, an easy one for me was there'd be a game class and then there'd be a player class. And the player data would live in the player class, and the ways that I would change the player data would live in the player class. And the same thing with, and so then maybe I'd even have a turn class just so I could like keep track of what all the turns were. You know, maybe I want to have this memory of like, this is the current turn, but I want to keep a list of what all those turns were. And so I would also create a turn class. Just you know, it was actually kind of a bit of overkill that I might not need, but I was thinking like, oh, it'd be nice to kind of have this over here. And my main goal is with code and with breaking it out into pieces is usually I want to have classes that do single purpose things so I can reason about them reasonably. So, thank you. Yeah. So there's a series, like there's a lot of books on how on patterns you can use to make OO make sense, to build apps with OO. There's this really well-known one. I'm trying to remember what the actual name is because generally referred to as the Gang of Four. Not to be confused with the Gang of Four, the kind of the political group, and like the people in China who after the Cultural Revolution were not those group of four and or Gang of Four, and not the punk band Gang of Four. This is like a different Gang of Four, but you'll see it referred to. I think it's just called design patterns. I don't know, but it was like they had a bunch of kind of OO design patterns. They're not strictly OO. You can use them outside of OO, but that was a big thing. But I will definitely say that getting used to defining your data and your data structures and your data operations in OO is in classes a big part of working in OO languages like Ruby. And I spent a lot of my time in C# and a fair amount of time in Java as well. And it was a similar thing that would happen. And sometime in C++, but I was never really a fan. I don't know that I understood the stack correctly. I should go back now that I understand more about how the stack works, I think. But that's like me just talking about me now. So yeah, this is one of the common cases for OO, or one of the common uses of OO is domain design. Can anyone tell me what domain, have an idea what domain means in this context? Yeah, the area of expertise, right? And so usually what we're talking about is like the thing that we are creating a model of a real world thing, right? So in the two-player math game, the nouns that we have are things like player and game and turn, right? Now you guys actually have some experience with a bit of domain design already. You had this experience starting in week 4 with databases, right? You'd create tables and you would define the relationships between them. You had to, like, we gave you a set of business requirements and you built out an ERD. With this sort of OO domain design, you're going to do similar things, but instead of making database tables, you'll end up making, you'll often just make classes. But there's a connection between classes and tables where we can have collections of things and we can have these sorts of relationships. So when you're thinking about object-oriented domain design, a lot of the ideas that you had in databases are going to fit, but now with extra things like, well, we also have inheritance, and we also have thises and that's. And there's not a strict, like, one-to-one to how the databases work, but it's going to be kind of a similar thing. And because of how, like, often, like, examples you see in OO are going to be about domain design. Another way, by the way, to describe domain design is if you were describing your app to your mom, how it would work. Yep, assuming that your mom is not a web developer, which I'm not going to assume. Your mom can do whatever she wants. But this is like, oh, well, there's a game, and one game has many players, right? And one game has many turns. Each turn belongs to one game. And oh, now that I think about it, a player can play many games. So they're, you know, and you'd start to like, these are just commonplace descriptions of the world that you're in, and you would kind of describe them with, then you might describe them with database tables or with classes. I had to remember to look at you guys because you're all so classy. All right, so it's a reminder, mnemonic aid, really. Anyway, all that is preface to today's lecture, which is on active records. And this is a really fun, I think this is the most fun lecture for me. Want to make sure I set your expectations appropriately. Because I'm about to show you the mechanism that that Rails is going to use to talk to databases, how it's going to organize its database operations. Now, what tool did you use when you were in Express to kind of organize your database operations? Connects, that's right. So I want you to, like, this is going to be doing everything that Connects is doing. It's going to be abstracting away database operations, but it's going to do it in a way that is different. And occasionally that elicits an emotional reaction from students. So we're going to see what happens. Okay. We're in the world of Connects for a moment. And we have a table. So let me go into pSQL real quick. And I'm going to create a table. What am I creating a table about? Turns? Dogs. Well, I could just do the two-player math game as a database thing. Is that what everybody wants? It's not what everyone doesn't want. So let's just start with one thing. I like dogs just because it's like a thing independent of itself. That you'd be like, yeah, dogs. All right, so create table dogs. I guess. ID, serial primary key. What do we? I guess I need a comma. What else? Name, right? Which I guess we'll say varchar 255. Not null. What else we got? Breed. Varchar 255, not null. Huh? Weight, which I guess is going to be a decimal. I should probably also say, like, right? When you have units, that might be in any given unit of measurement. It's not a bad idea to associate like what unit of measurement you actually have. So if you have weight, it's going to be in kilograms. You can let that know. So you're going to see a thing in the coming projects for this week where it has like price and it says price in cents, right? So you know, oh, this is an integer of cents, which makes sense. I heard myself. I heard what I just said, and it was adorable. And then I guess image URL. I'm not actually going to use the image URL. So, hey, Averthidi, how you doing? Good. So maybe that. Oh. Okay, cool. So now I have. All right. There's that. But okay. So let me create into dogs name, breed, weight kg. There's no point in doing a dog example without actually like looking at dogs, right? So somebody give me a breed of dog that we want to put in. Huh? Doberman. Of course you'd go for a Doberman. All right. Spirit. It really is. That is exactly your spirit animal. All right. Doberman. Doberman or Doberman Pinscher in the United States and Canada is an... Okay. So what is the name of this particular Doberman? Eric. Yes. Isn't it though? All right. Doberman. And weight for a male is about 40 to 45 kilograms. So we're gonna say that it's 45. It's a rather serious dog here. Okay, cool. So now select star from dogs. Cool. All right. So let's touch, model.rb. So we are going to, no, not there. Shoot. Cool. Okay, so what I'm going to do is I am going to connect to this database. I'm going to say require relative, connection, right? Which just, it says that it established a connection to a database and then it stopped. So I now have, I have a connection over here to the AR, Postgres, yada, yada, yada. You've seen a connection string like this. So what I can do here is I can actually make active record base. Yeah. There's a connection. I think it's .exec. I could have looked it up. So I can do a query from here the way that I could, do a raw query on connects, right? But, I want to, we've been talking about object-oriented domain design, so I want to be able to create a class that, I put all my stuff in. If this were connects, I would make a get dogs, get dog by ID, get dogs by breed, create dog, update dog. Well, I hate to say it, but delete dog. Yeah, no, don't delete me. All right. So what I'm going to do is I'm going to create a class. Right? Look at that classy dog. And then what am I going to want to have? Well, I guess I want to have, of course, initialize, name, breed, weight. This seems like a thing. I want to be able to save this dog to my database, right? Now this is going to be at name equals name, at breed equals breed, at weight kg, I should say. Weight kg. And then here, also I'm going to say that it has an ID of nil, right? Because we haven't really saved this to the database yet. It's a particular thing. And then I want to have a save that says hey, if ID is nil, else, come on. So if ID is nil, then I'm going to do like active record dot base dot connection dot, execute. And here I would execute like, okay, insert into thing, blah, 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 returning star, right? And then I would set my at ID to star. So what's the ideas of my record, right? But if I didn't, I would say, so this would be something like query equals, insert into dogs name, breed, weight kg, values, right? And then I'd execute query, almost forgot, returning star. It executes query with also name, breed, weight kg, right? And I'd say here results equals, and I'd say at ID equals results. I know, probably like this at ID. Right? So this is what I got to do to create it in the first place. But if the ID is not nil, then I'm going to say query equals update dogs where ID equals set name equals right? I say like all the things I'm going to do. I just say name first because I'm like, lazy. Active record, base, not basic object, base. Okay, so this is a lot of writing I'm doing just to do the initial save, right? And I haven't even done like get or destroy, right? I mean, send to a farm upstate. Right? So this is like, okay, so then I would want to also like add self dot find or a def self dot find ID, and this way I could maybe find, oh hey buddy, how you doing? I can do all my queries here, right? But this is a lot of stuff to write. A lot of stuff to write. It would be great if I didn't have to. So this is me just writing like a little bit of stuff. And with connects, you would have to write all those queries, right? Well, Active Record is an object relational mapper. It's able to kind of abstract some of stuff this way. So in order for me to have all this stuff, all I really have to do is say class dog extends active record base, and then I don't have to put anything. Like I am done now. 925, no less. So here's what I'm going to do. Let's find Eric, shall we? Let's find all the dogs to start with. So let's do dog dot. Is it dog dot all or am I? I've been using the Python query stuff, so my brain might get a little bit. Let me just say dogs dot all dot each do dog, and we're just going to go ahead and pee that dog. I get a lot of like really just cheap laughs out of that one. Okay, So it established a connection. I have a debugger here, so I saw that says select dogs.star from dogs. And there's my first dog, dog ID 1, name Eric, breed Doberman, weight 0.45. Yeah, that is weird that it would, I don't know, just because it's the decimal work, how the decimal probably works. There's probably a way to like make that a bit better. So let's actually put dog.name puts dog.breed puts dog.weight kg. Right? So now not only that, I didn't have to make methods to get the actual things. It's doing that with magic. That's all. That is everything. That is all of the description I have. Let's do a few more things. Eric equals dog.find 1. Let's take a look. Oh, look. So now it did another select query. Select dogs.star from dogs where dogs.id equals 1, limit 1. Right? And it got me that 1. How about this? Let's find all the Dobermans. Dobermensch? Doberman, yeah. Pretty sure that's the German plural for that. Equals dog. Matsuba, I could do an active record like just dog.where, like dog's the active record class. I can just do dog.where, right? Or do I have to dog? Okay, cool. Thank you. I've been using a Python ORM, so now my brain's like, is it filter? Is it? I forgot, but that's okay. That's what Google's for. Dog.where. I'm going to pass in a hash. Breed. Doberman. That should be approximately right. Right? Oh, look. Select dogs.star from dogs where dogs.breed is Doberman. Oh, and I have one. Huh. So now I have a bunch of query stuff just built because I wrote this. Now, mind you, all we've been doing is the browsing and the reading, right? But there's also editing, adding, and deleting. So here's what I'm going to do. Let's make a new dog. Shiba Inu. Such dog, much wow. All right. Okay. So, Doge equals dog dot new. All right, I'm going to, thanks. All right, dog dot new, name such Doge much wow, breed Shiba Inu, and what's the approximate weight of a Shiba Inu? 10. Wow. A Doberman could eat 4 Shiba Inu. Weight in kg is going to be 10. Oh, do I need to? It doesn't matter. All right, so let's take a look at the Doge here. Right? Now, you notice, okay, so I created this Doge object. You notice that its ID is nil, right? In fact, I can do a little, let's put, is it created? I'm trying to remember now. Undefined method created. Let's just look. Active record base. Morning, B. For the video record, she did hear me and say good morning back. It was like really quiet, so you might not have picked up the audio. She still doesn't know there's a joke going on. It's fine. Yeah, conditions. Oh, see, save. All right. Doesn't seem to be on this one. That's fine. So there is. Well, actually, I want to find a method on this. What I can easily do is just, there are methods. Oh yeah, that's right. I can actually inspect these things and find out what's available. So let's take a look. Holy crap! Woo! So methods much. Wow. All right. So weight kg before typecast. Name, weight kg came from user. Weight kg changed. Weight kg, it's kind of obsessed about its weight. Jeepers. Weight kg will change. Will change. Weight kg was, weight kg previously changed. So there's a lot of ways to keep track of like what has changed here. Now there's a lot of stuff here from dog. That has to do with like name, weight, and breed, right? But let's see if we can also find cache versioning. Oh, where types. Yeah, there's a lot of stuff happening here. There's a lot of meat on this dog. Changed attributes. So one thing we can do is we can actually take a look at ID. Unexpected. Oh, sorry. So there's no ID, right? So how do we actually? Now this is just one of the big things about the ORM is that it's an abstraction, and the abstraction is the narrative that we're following here is that there's this object in Ruby memory, and there's this database record, and when we make changes to this object in Ruby memory, then the database record changes, right? There's a thing like spooky action at a distance, right? So we can pretend that I'm just changing an object in memory, the way your two-player math game works. We can pretend that that's exactly what's happening, even though really we are making database operations, right? So, so we do have to, from time to time, just say like, okay, now make it go back. So right now we have an object in memory that is not an object in the database. So let's do doge.save. And then pdoge. So we said save. We had something with like nothing there. We saved it. You notice there's the green color. The green is creation. It inserted into dogs, name, breed, weight, key, G, values $1, $2, $3, returning ID. Right? So it did all the things that I had to write before, just taken care of. Which I think is dope. Yo. That's right. The first one wasn't, and it didn't have the ID that said it's added to the database. So now it is. Let's update this doge. Let's say that he's been eating snacks and gaining weight. Doge.weight kg plus equals 2. Right? Now we can kind of use those doge methods, some of this gigantic list, to find out, like, hey, puts doge.weight kg changed, right? Oh, yeah, we're just creating those. So now it says, yeah, that totally changed. Okay, cool. So now we're going to save that. We're going to say save, and now this is going to create a yellow one on our login, which is an update. We have updated the value, so now that dog is a 12-kilogram dog, right? Okay. Well, we have browsed dogs, been able to do a query on a collection of dogs. We have We have found a specific dog. We have updated a dog. We have added a dog. Angela? Yeah, you have to save .save just to kind of get it sent to the thing. There are... Well, you can like make a bunch of edits and then say .save and it'll update with whatever it is. Yeah. You had a question. Oh, by the way, sorry, I realized I forgot to actually ask the question. Her question was if you have a bunch of operations, do you have to save after each one, or can you kind of put them up? So basically, the save just says synchronize my database record with what my current thing looks like. So anyway, your question?
For the class.
And I think what she was really getting, I'm sorry. All right. Go ahead. This guy.
You know how you create a class?
Yeah. Great.
When you create a class, does it automatically do like an ATR?
Okay, so when you create a class, does it do the accessor? You could, the adder like ATR. Yeah. You can think about it doing that. It actually uses a different mechanism called method missing, which is.
You can read write whatever you want.
Yes, assuming, but it's going to be like if you try to change to stuff that's not like there. So you can read write to anything that has an allegory in the table, but yeah. Yeah. Will it rewrite their ID every time? No, it will not. Once it has an ID, it's just going to update based on that ID. Yes, you're correct, because we keep on creating new ones. We haven't destroyed any of them yet. Yes, you are right. It is an update. But I've been waiting till now to get you guys emotionally ready for what was going to happen next. To be sent to a farm upstate where he can run around with his other friends. All right. So now we've done the save, and there's one more thing to do. I shouldn't have picked something cute. All right. Yeah. So, all right, so now the destroy does delete from dogs where dogs.id equals 1. That's number 5 now. And yeah. So that is the life cycle. So we can do Brett. Honestly, I should not have let you get emotionally invested in this particular example. So you can kind of see in my thing here, I have blue for queries. I have green. I have green for creation, yellow for updating, and red for deletion. And all of that I got with this much code. Okay, so here's the other thing that no one's asked. On this, if I made a series of connects queries to do all this, right? I would have to do something to the effect of, I would have to say like, okay, connects dogs dot select star. I have to do some things, right? Here I don't seem to have to. Do you notice that there is nothing that says, oh, by the way, the table I'm looking at is dogs? I just made class dog. It is dark magic. So what's really happening is that basically Active Record, it knows which I told it specifically which database to connect to. So when I said I want a dog class, it looked over the schema for an existing dog class. And then, or it looked over the schema for a class called dogs. And having found that class dogs, it looked over the schema. It found, oh, I have a name and a breed and a weight kg. It made all of these methods generated immediately for name and breed and weight kg, as well as ID, but yeah, it's a different story entirely. And created all of my methods of how this would update based on the dogs table. and it does this at runtime. Like it does this when I set up this class. It did a check to do that, and that all happened automatically, which is, I think, dope. All right. So, and I didn't have to write all of this stuff. That is active records. Now, generally at this point, there's kind of one of two reactions. Either of them are appropriate. It's basically one of 5 reactions: anger, denial, bargaining, depression, acceptance. No, there's a few. There's a few reactions. The first is, well, this is amazing. I can't believe how I'm angry about Connects. I am angry. I was so much work. Some of you shed literal tears. I'm not saying who it was. I just noticed some of you giggling louder than others. So, so then we had that was like part of it, and like clearly this is a much easier way to go about connecting to a database, right? Like in terms of the code you have to write. But then some of you are looking at this being like, that's dark magic. Yeah. Well, there basically is, you know, there's equivalent exchange. You take some energy out of this part of the world. You want to create life over here, you got to destroy life over there. And so that was way too dark for me to be giggling while saying that. That's fine. And so what ends up happening is that there is a trade-off for all this magic, which is that you don't know what's going on, right? So and what ends up happening is that if you want to do things that are kind of just in the normal line of like, yeah, that totally works, no worries. You can do most everything you want to do. If you find yourself in a hackathon, just wanting to be like, hey, I just want to generate a bunch of like databases and database code really quickly. Well, this is your thing. That's cool. But the flip side of it is that when you're working on an app and you want to like make performance enhancements or do some sort of like you want to do queries that just kind of fall outside what it wants you to do, that's where it gets tricky. So I'm basically, this is the catch. I'm telling you what the catch is so you won't sit around wondering what the catch is. All right? That's I don't know, anyone fans of the show Angel? There's one point where there's this like evil law firm they've been fighting for 4 seasons, and the evil law firm was like, okay, here's the keys. You're in charge of the law firm now. And they're like, what? And they're wondering like what the deal is, and the catch is that for them is that they have to keep the law firm going, which means they have to kind of keep on dealing in like gray areas and make the whole deal. That's not the point. The point is that this is the catch. The ease that you get for like small stuff tends to break down over time. And these aren't necessarily, they're optimized for correctness, for like being able to generate a bunch of correct methods, not necessarily optimized for performance. Yep. Right. So the question is, can you use active record, but when you want something more specific, right? Like, yeah, you can write like a raw SQL query if you need to. Yes. This is, okay, the question is this just a Ruby thing? And active record is, yes, a Ruby thing. But ORMs exist all over the place. And it's actually not that hard to generate something that generates, like, JavaScript's really easy to make code generations. You can generate code that, like, you can write things that write this much code for you, right? So it's not impossible to say, like, hey, write something that says go over my schema and generate something. So you can find ORMs for Node as well. You can find ORMs in all sorts of things. And they do, I used one for a long time in C#. I will tell you this. So I used one for a long time in C#. It was called Entity Framework. It's the one that kind of comes standard with the .NET framework. And what I found is that after dealing with this sort of stuff for a while, when I saw connects, I was just like, oh, that's so beautiful. Because you can have like such fine-tuned control, right? After having done so many like uh, really wacky like queries, or like trying to find a way to do a query or like run a view or something like that, and finding like I couldn't really get that close to the metal on the of my database. Like I couldn't really get close to the database. It was all like hidden behind abstractions. I didn't know what would break what, or I didn't know if like, oh, running it this way will actually cause the whole entire thing, cause the entire house of cards to fall down. This was I really like those as well. So okay, what we're gonna do is, now that I've shown you this, we're gonna have some of that coffee. That coffee I keep on hearing the kids talk about, and then we're gonna come back and we're gonna do some more. We're just gonna do some more wacky shit. All right. Okay. Right. So, okay. How's it going, everybody? I want to make sure I still got, yeah, I still got audio. Cool, cool, cool. Cool. Cool, cool, cool. So, the no, what's another thing we did with Connects? So with Connects, we had a lot of database transactions, all sorts of database transactions. How are you doing, friends? But there was this one type of database transaction that Connects had. The one that you would use, that you would get, you'd run them once you get a new what's it in. They would help change the schema a bit. And what were those? Migrations. Migration. All right, that's right. So we have the same ability. Now, I'm not going to get into migration, like Rails will have a good migrations kind of engine with it. But with Active Record, we can certainly define schemas. So let's do that. All right. Right now, for that last stuff, we were basically like we'd already created a schema, we already created data in the P-SQL, but let's do some schema on our own. So one of these numbers, one of those numbers, a little bit of this stuff. All right. Require relative. Connection. Okay, so I'm going to say active record schema dot define do. Right? So within this, we're going to be able to do the things that we were doing before. Now, I will say another benefit of, well, I say benefit. One of the things about Ruby is that it is a lot more synchronous by nature. So instead of having to put together promises, there's someone talking in this room behind me. All right. So we are going to do this kind of one at a time. And we don't have to chain promises. I personally like promises, but that's another story entirely. Create table. All right, so we're going to create a table. Now we could do the whole game thing, right? Yeah. So let's create table games, right? And when we were doing this with Connects, we would say create table. We'd say the name of the table that we're using, and then we would pass in a starts with a C, ends with an all back. Come on. It's a callback, right? A callback that would take in a table definition object. Well, we're going to do a similar thing here. Of course, how do we do callbacks in Ruby? Blocks. That's right. So let's create a block. So we can say t dot. We don't really actually have to say the increments part, which is nice. So we're just going to say maybe date, which is just, started. I'm now double checking to see if, yeah, cool. So there's the time, the t dot, the type, and then the name of the column, right? And I might, okay, so let's do that. Ruby schema RB. Cool. So now we see a couple things happen. That purple is a change. So create table games, ID, big serial primary key, started, date, right? Very nice. Now, of course, we want to add more stuff to this. So let's say that we really want it to be like, t date started, t dot, I don't know, current player. Maybe Yeah, we'll have t dot current player, or sorry, t dot int. Is it int or integer? I can't remember. I'll find out in a second, I guess. Current player, right? So that's good. So let me create that. Oh no, it's mad at us. Why is it mad? Super mad. Duplicate table. Error relation games already exists. Oh no. So what I'm going to do is I'm going to say drop table games. And this will be happy. Now, the thing about this is that I already had the games class. If I go to my pSQL AR demo, drop table games, and run this again, it's going to be mad for a different reason, which is that it can't do that because there's no games that exist, right? Now, I wish it had drop table if exists, but it's more like if active record dot base dot connection dot, I think it's like, let me see. I'm going to double check just to make sure I have the right syntax. Table exists. Connection dot data source exists. Sorry, data source exists. Games. Yeah, it did. Solid catch. 10 points to Hufflepuff. Solid catch. Okay. So now this makes sure that I have that first. Create table games. Cool. And now I can say, I can also be like t dot boolean. Is it bool or boolean? I guess I'll find out in a second. Is over. Let's find out that. It's mad because undefined method bool, and this is one of the things I love about Ruby. This is one of the things I do like about Ruby. Did you mean boolean? Maybe. It does do that a lot. Especially to Jeffrey. Okay. Right? Okay, cool. So I have all this stuff. All right. Now, I can't really play with this stuff in my code until I create a model for it. So I'm going to say class game extends active record :base end. And I can say game dot. I can say game dot new and then put stuff in here. Started date. Is it date dot now? I want to say. Again, we'll find out in a second. All right. Unlike yeah. So sorry. This should be game dot new. And then I have to say game.save, right? Those are the two steps to create a game? No. Undefined method now. Okay. Started at... How about that? Okay, that seems a little more reasonable. All right. I'm pretty sure at that point, like, we were kind of like just figuring out farming. As I think maybe by then we actually had by 4073 BCE we actually had like the written word maybe. And I think there was like Sumerian cuneiform, but We were still writing in C++ at that point. Yeah, sort of. Well played. All right. Okay, so yeah, so now we have created a schema and a thing. So let's say that I want to create. Oh, should I do associations now? Yeah, I'm going to kind of throw associations in here too. Okay, let's say that I actually want to create. I want to create players. Create table. Players. Do. Another T, and I want to say player dot. Oh, not player dot. I want to say just T dot name. T dot T dot text name. T dot string name string. Yeah, that makes sense. Name. Right. We can also say like null false to say like, hey, this is absolutely required. Right. And I think there's a way to do defaults as well. Yeah. Let me see if I can do default false. Right. So I can have default as like, yeah. Anyway, string name null false. And yeah, that's a start here. And I'm also going to say drop table. Because they're not touching, I can kind of do like one after the other. But generally speaking, you're going to want to drop them in reverse order how you created them. So players, class player, active record, base. Okay. Or should I make it so that it's just a player for this game? I'm going to make it a player just for this game. So, so that means that then a player has to be linked to a game, right? So then I have to say, well, I have to say something like t.integer game ID, and maybe have a foreign key like constraint later. Well, one of the nice things about this is it actually has a really smart way of writing this. T.references game. And I can write foreign key true, and then that puts a foreign key constraint so that like I cannot have a game ID that does not exist as an ID in games, right? Makes sense. That's what a foreign key really is, just the constraint for the sake of data integrity. But now that I have that, and now I definitely have to drop that first. Yeah. So we can see here, created player's game ID, big serial primary key, game ID, big int, name, character varying, not null, constraint, fk rails, blah, 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 foreign key game ID, references games ID. All right. I'm also might throw a null false here. And that's going to say, also big int is not null. It cannot be null. All right. Now, so that's nice. That's a handy little syntax, right? I don't have to say what it's just a references, and it does the rest of it for me. All right. Cool, cool, cool. But now I want to be able to create a link between these two. So I could say game.save. I can also shorthand this to just game.create. Started time is now. Right? And I'm going to say player1 equals player.create. So .create is do an initialize and also save that. Right? Player.create name is going to be Benji. And then I have to add a game ID, right? game ID is game.id. All right. Okay, so we created our schema. We inserted a value into games, and then we created a player named Benji for game ID 1. Cool. So then how would I find out who Benji's game is? Well, I guess I could say Benji's game is fact. Benji. Benji's game is well, I guess game.find Benji.game ID, right? And I have to keep on adding this together to do that. But it would be nice if I could actually link this in a way to do. There's actually another kind of more semantically meaningful way of connecting these, right? So I'm going to make another player. And what I'm going to do here is I'm going to add something to this player class. I'm going to add an association. I'm going to say that this belongs to an entity in the games class, which is of course also an instance, or an entity in the games table, which is an instance of the game class, right? So I'm going to say, so I'm going to have to create a bunch of def game, right? And I'm going to write, return, not return, game.find game ID, or game.find is going to be game ID, right? I have to create that. Or I can say belongs to game. So I'm saying that the player belongs to a game, and in other words, now that when I have a player, I have a game. So I could say Angie and then just find another G name. That's Ben space G. All right. So Angela equals player dot create name Angela. Game. So now I'm linking the actual object, and when I want to see Angela's game equals Anglia dot game. Okay, so that kind of simplifies this out in some ways. But there's one more way I could restate this same thing. If a player belongs to a game, then what's the other way we could say this? Not a game belongs to player. Like, there's a one-to-many relationship. A player has one game. That means that, and then a game has many players. Game has many players. These are now the flip side of this relationship. And so what I'm going to say is I'm going to pick one more person. I feel like I don't pick on Sylvia enough. So Sylvia equals. Now instead of having to define game ID here, what I'm going to say is that Sylvia is game.players.create. Game.players is now a subset of the players table that belongs to game. We can think of it almost like a table on its own. So I can say game.players.create name Sylvia. And all right. Yeah. And if we look at these three, what we will see is that they kind of look exactly the same, at the out. We just used a few different ways of describing how to create them, which is pretty handy. And now if I say pgame.players, I can see all of those players. If I wanted to, if I said game.destroy, it will be like I can't do that because key ID 1 is still referenced from table players, right? So what I have to do first is game.players.destroy. And I think I might have to do it game.players.destroy. Yeah. Select players. .destroy all. Right? And then it goes through. Now this is one of those things where it's like it's correct but not necessarily efficient. It does a delete query for it does a select query first and then a delete query for each of them. As opposed to just, hey, delete from players where game ID is blank. Right? Correct, not necessarily the most efficient. Yeah, this is something you do with, like when you want to just delete. If you wanted to delete a game, you have to say game.players.destroy all and then game.destroy. No, this is like if you wanted to remove this game and its players from your database. Yeah. You could keep all that. I'm just showing how you would have to destroy it if you were to destroy it. You can also do a on delete cascade. You can have that on there if you wanted to. Okay. Delete from games where games. So that is an example of the stuff we can do with an association. And the thing about the association is that this doesn't give you any new powers. It's just a kind of a more semantic way of reading it. And then you will find long enough that being able to read and understand a line of code within like honestly fractions of a second is really valuable. So what I like about this game.players.create name Sylvia is, oh, I'm creating a new player for that game, right? It just reads a little more semantically like this is what I'm trying to do. Okay. I'm honestly just spilling on myself. I'm such a mess. All right, I did schema and associations. I'm going to get a little bit into 10:20, so I have time. Cool. So I want to get a little bit into queries. I have sort of KV was sitting over there, but I just have James not listening, keep me honest. All right, good. So one of the when it comes to the EAD part of bread, or the cud of crud, there's sort of limitations on how you're going to do that stuff, right? There's usually not very many variations of what you want to do. I want to create a new thing, or I feel like I want to create a new thing, I want to create batches of new things, or I want to update things. Or you might find yourself where it's like, I want to update a query that then updates the actual, like, that's a funky one. But for the most part, it's actually pretty straightforward what you want to. The editing isn't as like it's pretty straightforward what you can do with editing. There's only so many variations that gets tricky. Queries though are, they can go nuts. So let's actually I'm going to copy the schema to queries. Okay. So actually that I'm going to leave there. So we have these. I might, okay, so we have a bunch of players. We have that. We might have also t dot int score default 3. Let's do a clear first. Okay. This is saying, did you mean inet? No, I meant integer. Okay. Cool, cool, cool. All right. So, we can build queries, right? Get rid of this, get rid of that. I don't even really need to keep track of Angela or Sylvia. Okay, so let's start with game.all. This is how we would do a query. So if I did game.all each do game, game. At the end here, you see it did a select games, star from games. Current player nil, is over nil. I think I want is over to be default. False. Right? But basically, this game.all represents a query of all of the entries of the game, right? So here's the most important thing to understand about game.all. Query equals game.all. Query.each. So I have this query. I say query.each. So the question is, where puts is, has there been a query executed yet? I see little shakings of the head. I see little noddings of the head. Has the query been executed yet? So the question is, when I run this, am I going to see this before or after that SQL execution? It's going to be right before. And why is that? Well, there's lots of things to consider, but the main thing is that queries, and this is actually true in Connects as well, but queries are lazy. And what do I mean by lazy? Lazy in this world means that, versus eager, means that it doesn't get the results until it absolutely needs them. Now imagine that I have two assistants, Charles and Benji. And so Charles is an assistant with an eager strategy. Benji has a lazy strategy. So I go to Charles and I'm like, hey man, listen, I'm going to need some chips. And he just runs out the door. And I don't see him for like 15 minutes. And he comes back and he has computer chips and potato chips and paint chips and poker chips. Right? Wood chips. A DVD of season 3 of Chips. Right? Like, no, man, I meant like tortilla chips. And then he's gone again. Comes back 15 minutes later with all sorts of tortilla chips. I'm like, okay, because what I'm trying to do is actually make nachos, so and like I'm gonna need cheese, and then he just runs off again, right? This is an eager strategy, and it's not necessarily so effective. So imagine I say to Benji, like, I'm gonna need some chips, and he's like, yeah. I'm like, yeah, some tortilla chips. He's like, okay, and like some cheese, and like pickled jalapenos, and maybe some sour cream. He's like, mm-hmm. And like salsa. He's like, yeah, I get it. Those are, I could imagine a person wanting these things. Is there a particular time that you're going to want these things? Like, yeah, I want to make nachos for lunch. Make nachos for everybody. Like, cool. You will have your nachos. And then he goes back to napping, right? And then when like 12 o'clock is about to come by, like 11:59, I'm like, oh, where's Benji? 12 o'clock. He just ding, shows up. He's got all the ingredients, right? He's got the right stuff at the right time. He spends as little of his effort as possible. He just like, look, I know what I need to get. When you actually need it, I'm going to get it. So there are certain methods. Yeah, it's just his style, right? And where you might think like, the idea is like, well, that seems a little bit, I don't know. It seems like a lot of times like, well, why wouldn't I want the thing I want right now? But this lazy stuff helps us like create bigger and crazier queries. It lets us know when things are going to be executed. We don't have to like, we can pass around a query, keep on adding stuff to it, and then like, when it's needed, then it's needed. We can also cache the result of a query once we've gotten it. So this is, there are basically some times when I actually need the information, but until then I'm kind of cool to keep on building stuff. So at this point I could also say, hey, query equals query.where, and I could say, was it is finished? Is false. So I can add stuff to it. Again, has there been a query yet? Oh, is it not where games is finished? Oh, is over. All right, there, loud outside, right? So now I've built this query up, and then I want to execute it. So what things actually cause a query to be executed? What methods? Well, things that we would use like where and select and kind of like in or that sort of stuff, that's not going to cause it to happen. The things that would be like building a more and more SQL, no. But when we actually want it on our program, if we do .each, well, then I want to do something with each record. That's the time. When I want .count, when I want .find, when I want .any, right? When I want to say .exists, yeah. When I want these things where it's like I actually need to know a thing in my program in Ruby now, then it's time to actually execute that query. In the meantime, I can still keep building up a query, and in fact, I can say, at this point, well, what if I want to see kind of what that query is shaping up to? Then maybe I can, well, let me take a look at my methods just to see that if I have it right. Query.methods. Whew, so many methods, right? This will let me any, one, none, values, blah, 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 locked. First are create, delete all, model, yada, yada, yada. There's a lot of stuff here, but what I'm looking for is come on, where are you? Yeah, psych YAML to you as well, sir. To JSON to YAML, lazy to set to XML as JSON. Come on, where are you? Let me just write query dot yeah, okay, so to SQL will actually let me see the SQL that will execute. So if I'm building a crazy query, I can actually see, oh, here's that SQL that will execute. And then I can kind of put them together. So I know, okay, this is what I wanted to see. This makes sense, right? Now it's going to actually create this SQL when all is said and done, where it has $1 here and it creates that. So there's going to be some differences. But this lets me start building up a big query and then inspect it as I'm going along, which is pretty handy because I can end up making some crazy queries. So So yeah, that lets me inspect it. And again, if I can do toSQL, that means it's not really run yet. So then I can rerun this. So yeah. So that is a handy tool for being able to look at my queries. Okay. There's more stuff we can add here, as you may have seen. There is a query interface that we can take a look at from the Ruby on Rails guides that has a lot of cool things. So, for instance, by the way, these are the list of things that will actually cause it to happen. There's ego load, from group. Each isn't on here. Each should be on here. Dot find, yada, 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 select where. Oh, no. No, each finder method allows you to pass arguments into it to perform certain queries without writing raw I don't know, whatever. Retrieving a single object, find, take first. Find each, batch size. Yeah, we can do array conditions where we can pass in arrays. Hey, where it's in a number of things. We can placeholder hash conditions. This is usually how I usually use hash conditions like this, where created at. Nots, ors, ordering. Yeah, so there's everything that you could do with SQL. You can do. I think there's a couple of things I found that were like I had to write actual SQL, but I think union was one of them. But for most of the queries that you're going to write for a lot of your lives, unless you're doing some crazy SQL, this is going to be enough for you. So you can do selects, you can do limits, offsets. Offsets are great for you doing pagination. You know, if you're like taking a page of 5 each time, and you want to do page 2, then limit 5 but offset 5. You can do groupings, halvings, overriding conditions. Yeah. So all the things that you would want are available. Are there... Oh, okay. One more thing I'm going to show you. And that's mostly because I love yelling. Okay. So, here, we use the create method. There is create, which will let you know true or false. It'll like give you a thing, but also might give you nil. But it's pretty chill in terms of what it does. But there's also create, which has what it'll do is it'll throw a proper error if it can't create it for whatever reason because of the validation failing. There's also save and destroy, which is one of my favorite ones to yell, which I have to do in my professional capacity. Just making sure Benji's awake. Yeah, so that is... So usually when you have like save, especially, save will give you a true or false based on when it happened. But save will actually, based on validations, like throw an error. So you might want... So like we said, when there's an exclamation mark, that means that there's like a version of it that's a little gentler and that version of it's a little more aggressive, a little more abrasive, in fact. And the more abrasive version is throwing errors as opposed to just kind of quietly. You can check to see whether it failed or not, but it doesn't raise an error. Throw an error. My Ruby authority is over there. Without causing an exception and breaking your flow, right? So you may want one or the other, but that's the idea between that. So yeah, are there any questions on what we've seen today? Sweet. For the breakout, we're going to be talking about more active record features, validations, callbacks, maybe callbacks. I don't know how I feel about the callbacks then. But that's not the point. So, and then I'm trying to think what else. Yeah, there's a few other active record things that are fun, but writing validations is also cool. So, if there's no further questions, then I'm going to go. I guess I'm not going to close that yet.